Now, what we're doing today is an extension of what we've been doing with factoring. And I think from what we covered, what I saw y'all doing on Thursday of last week, y'all are starting to feel pretty comfortable with factoring. Yes? Our two sets of parentheses, finding our signs, factoring out. Yes? Because the stuff we did Friday are two sets of parentheses with three spaces.
Yes.
Found the sign, factors of the first term, factors of the third. This will be the exact same thing, except we're adding one step in. And the step that we're adding in is greatest common factor, GCF. So whenever we look at any quadratic, any of these higher degree polynomials, the first thing we really want to look at, is there a greatest common factor? Is there a number in a term that will divide into all three? That is in common in all three. So when we look at this here, is there a number that goes into 3r squared, 21r, and 30? 3 goes into all of them, yes? So we can factor it out first. We're going to divide each term by 3. Well, 3r squared divided by 3 would be r squared, because 3 divided by 3 is 1. Plus 21 divided by 3 is, then we'd have r plus. So if there is a number, a greatest common factor between all three terms, then we're going to factor it out. We're going to do this first.
Okay. So that right there.
If r squared plus 7r plus 10, if it is not factorable, if I cannot write it in two sets of parentheses, then yes. But if it is, then we need to factor it.
Okay. So what we're doing is we're taking that and we're doing both day Friday.
Yep. So all the stuff we've done up to this point, there's not been a value in front of the squared term, the variable squared term. So this will be the first time we're looking at a quadratic where we have a number in front of r squared. Now this time here, it worked out that, hey, all three terms are divisible by 3, the number in front of r squared, so we pulled it out. Because whenever we pull out this greatest common factor, it makes it a little bit easier to work with. Okay. And now everything else is going to be the exact same as what we've been doing so far. So we need to find the signs. Plus and plus. Since the constant, or the third term, is positive, the signs are the same and they match the sign of the middle term, which is also positive. So positive and positive. Factors of the first term and r. Those are the only factors. So we could have 1 in r squared, but it's actually not going to work for this here. And I can show you why here in a minute. And lastly, we need to find the factors of 10. Which ones do we want to try first? 2 and 5. And last but not least, we need to check it. And when we check it, we're trying to make sure that this comes up 21, right? Yes. Because the middle number comes from this product of these here, the sum of r times 5 and 2 times r, the outer and the inner, is where that middle term comes from.
After we get the r, are we going to
So would we really want to look at 21? Well, no. What number were we trying to check it with? 7. Because how did we get it from 21 to 7? We pulled out the 3. So once we pull out a greatest common factor, we're not really looking back at the original problem, this here. We're looking at this one here, because that's really what we're factoring. Right, I was throwing that in there to see if y'all would catch on to that or not.
So did I?
Yep. So here, when we multiply r times 5 would be 5r. 2 times r is, and 5r plus 2r is that what we wanted?
You know what that kind of sounded like? 7R. Kind of sounded like 7R.
And that's it. That's all we have to do for these here. So the only real change from what we did last week is the greatest common factor, having a greatest common factor. Any questions on this here? So let's look at another one. So when we look at this here, so we do have 2p squared, so we'll need to see, is there a greatest common factor between all three terms?
2, 14, 24. Yes.
It is. Two will divide into all three evenly. Because 2 divided by 2p squared would be p squared. 2 divided by 14p would be 12. 24 divided by 2 would be 12.
No.
Any questions on any of this here? So we want to see if this factors, and most all the ones that we're going to cover and deal with are going to be factorable. So we'll be able to factor them. Now, since the third term is positive, our signs are the, and they match the sign of the middle term. So we would have plus and plus. Now we need to find the factors of the first term. Factors of p squared are going to be what and what? And p and p. Factors of 12. 1 and
12, 2 and 6, 3 and 4.
And one of the things that's interesting, if 2 and 3 are factors of a number, 6 is as well. The only way 6 can be a factor is if 2 and 3 are a factor as well. Which ones do we want to try first? Three and 4. I want this color. And then we can check it. P times 4 would be 4p. 3 times p is 3p, which gives us a total of 7p. Is that what we wanted? So this here is our answer. Are there any questions over any of this here? Or do we feel comfortable with these here? We feel good with these? All right. Let's do one like this here. And we'll do, so 1, 2 more at least. So here, is there a greatest common factor between all three terms? Yes. What is it? 2. So 2 does go into 2r squared, 2 does go into 16, and 2 does go into 30. There it is. Sorry, I was trying to get this calculator out. So we can factor 2 out. If we factor 2 out, what we'll be left with is r squared minus 8r plus 15. Any questions on how we got to this point here? Now this here is factorable. So we look at the third term, and here our third term is positive 15, yes? So since it's positive, our signs are the same, and they match the sign of the middle term, which would be negative and negative. Because when that third term is positive, the signs are going to be the same and match whatever the middle term is. Because a negative times a negative gives us a, yep. Factors of the first term, r squared would be r and r. We only have 2 factors for 15. We have 1 and 15 or 3 and 5. So which one do we want to try?
3 and 5.
So if we try 1 and 15, r times negative 15 would be negative 15r. Negative 1 times r would be negative r, which would be negative 16r. So 3 and 5, because r times negative 5 would be negative 5r. 3 times negative 3 times r is negative 3r, which gives us negative 8r. And that's exactly what we wanted. Any questions on any of this here? Let's do one more together, and I will give you your assignment. So we're going to look at this one here. 3b squared minus 3b minus 36. So what number will go into all 3? 3. Because 3 is divisible by 3, 3 and 36. Because 3b squared divided by 3 would be b squared. 3b divided by 3 is just going to be b. And 36 divided by 3 is what? Our third term is positive or negative? So our signs are negative and positive. Does it matter the order I put these in? So we'll maybe need to flip them. We'll see. Factors of the first term, b squared would be b and b, because it's just b squared. We don't have a number written in front of b, so it's just going to be b and b. Now we need to find the factors of 12. Well, 1 and 12, 2 and 6, 3 and 4. 3 and 4. Do we have a preference on which one's positive and which one is negative?
3 would be positive.
So again, just like how I have a choice of picking where I put the positive plus and minus, we can pick which one spot we put the 3 and 4. Now we can check it just to make sure we have this set up right. B times 3 is going to be 3b. Negative 4 times b is negative 4b. And 3b minus 4b is negative b, negative 1. Is that what we wanted? Yes, it is, because they do line up. And that is what we have here. Now we do have other ones that we could do, but I feel like y'all are comfortable with this here, and having some practice would be better than doing more together. But there's one that I want to look at. We're not going to actually finish it or solve it today, but it's the one I want to look at. This here. Looking at this here, is there a greatest common factor between all three terms? Yes, there is. It's 3. So if we factor 3 out, 6 divided by 3 is? 6 divided by 3.
6 divided by 3 is 2. So that's
Guys, be nice. 15 divided by 3 would be? And so do we still have a value in front of x squared?
yes.
That's what we're going to be doing next, is factoring it when there is still a term left in front of a. Now, the overall process of what we're going to be doing will not change. We'll still have the same steps, but we're now going to have factors other than x or a or whatever the variable is. So we can have numbers. And we'll come in contact with that.